In this video, we're going to learn about aqueous solutions and pH. So, basic principle of water is that it will auto-ionize. And by that, I mean that if you have two water molecules, one will act as an acid and the other will act as a base, and you will have an H plus transfer over to an H2O, forming H3O plus and leaving OH minus. Now, this doesn't happen to a huge extent. Actually, if it's just pure water, and this is at 25 degrees Celsius, you'll have 10 to the negative 7th moles per liter of each of these two present. Now, what this means is that our Kw, it's called the water constant. It's an equilibrium constant. It is equal to the concentration of H3O plus times OH minus, and again, at 25 degrees Celsius, that is 1.0 times 10 to the negative 14th, wherefrom you can get to this. These two values multiplied together give you the Kw. I do want to point out that at 25 degrees Celsius, this holds. If we raise the temperature, Kw will be something else if we lower the temperature as well. But in this class, any calculations you do will involve that 25 degrees Celsius. As a reminder, acidic solutions have greater H3O plus than OH minus concentration, and basic solutions will have greater hydroxide than hydronium concentrations, and that's all there is to it. So if we want to calculate the H3O plus concentration and the OH minus concentration in a 0.5 molar solution of HCl, what we can do is say that HCl is an acid and it dissociates 100%. We know this because it's a strong acid. So if we say that the concentration of HCl is, we're going to make the assumption that it's basically the same as the concentration of H3O plus. Yes, there was a tiny, tiny, tiny little amount of auto-ionized H plus that was already there from the water, but it is so negligible, 10 to the negative 7th molar as opposed to 0.5 molar. Huge difference, it's negligible. So we'll make this assumption that this 0.5 molar concentration of HCl is equal to the concentration of H3O plus, because we know that HCl plus H2O 100% goes to H3O plus Cl minus. So based on that assumption, we can use the Kw, which is Kw equal to 1.0 times 10 to the negative 14th, and this is equal to 0.5 molar. That is the concentration of H3O plus, in this case, times concentration of OH minus. And if we did the math out, we would find that our OH minus concentration is equal to 2.0 times 10 to the negative 14th. That's equal to concentration of OH minus. So we've got our two answers. Our concentration of H3O plus is going to be, H3O plus, my word, there we go. H3O plus is equal to 0.5 m, and I realized I forgot a unit for my previous, my 2.0 times 10 to the negative 14th, but these together are our concentrations. These are collectively our answer to the problem. So there we go. Great. Now let's say we have a 0.020 molar solution of magnesium hydroxide. In that case, we should probably write out the equation MgOH2 yields Mg plus 2 plus 2OH minus. And I'm skipping the phases here, but these are aqueous ions and this is a solid. So if we know that we start off with 0.020 molar MgOH2 magnesium hydroxide, we can look at it like this. We can almost look at it like we start with 0.020 moles per liter, and we know that we have a 2 to 1 ratio, a 1 to 2 ratio here, where there's 2 hydroxides for every 1 magnesium hydroxide. And so if we're trying to find this, we would say our value is going to be 0.020 mgOH2 times 2m OH minus over 1m mgOH2. All I'm trying to do is show that we have a higher molarity of hydroxide than we had of magnesium hydroxide. So we end up with 0.040 hydroxide ions, and that will play a role when we're doing our calculation because, well, this is one answer, which I will circle with yellow again, I guess. But now for our hydronium, which I'll do just for fun in red, Kw is equal to 1.0 times 10 to the negative 14th, always at 25 degrees Celsius. And that is equal to my 0.040 molar hydroxide times my concentration of H3O plus. Now, what is the concentration of H3O plus? We can do the math, and we get to, it's going to be 1.6 times 10 to the negative 11th. And this is with the right number of sig figs, because we have 2 sig figs in our measurement. So there we go. I'll circle this in yellow again, just so that we have our other answer circled, except somehow it changed to teal or gray. All right, those are our 2 answers though. Now, those are concentrations, but we haven't dealt with pH and pOH yet. So pH is defined as the negative log of the concentration of H3O+. If the concentration of H3O+ is high, you'll know it, that would be an acidic solution. But if the pH is low, right, then it's going to be more acidic. And that's due to the fact that this is a negative log. So high concentration of H+, high acidity. Low pH, high acidity. High pH would mean basic. So take a second to read these. And another important fact is that if we know that Kw is equal to 10 to the negative 14th, well, we know that pH plus pOH will be 14. So notice that 14 comes from this exponent right here. Negative 14th, I know, but it's the negative log, so we get rid of the negative sign here. So if you know your logs very well, then this probably makes a lot of sense to you. If you don't, you can definitely tell like the 14 and the negative 14, they're there for a reason. But let's do a calculation and see how this can work out. This chart I'm keeping here just so that you can see it. It's very, very useful because you can get basically from any value, whether it's pH, pOH, concentration of H plus or concentration of OH minus, you can get from any one of these to any other in either 1 or 2 steps. So in this case, we're asked for a 2-step calculation because we've got the pH of 3.20. We're starting here and we're getting here to the concentration of OH minus. And there are 2 paths that we can go by. So let's do either. Let's actually start by going down and then to the right. So if we know that pH plus pOH is 14, then we know that pH plus pOH equals 14. We know that 3.20 plus pOH is equal to 14. And then therefore the pOH is going to be 10.8. So that brings us to here. Now we can move right from pOH to concentration of OH minus by knowing that the definition of pOH is negative log of hydroxide. So 10.8 equals negative log of OH minus. And you may not be as familiar with logs, but the inverse operation of the log is 10 to the something. So if I take this negative sign from here and I move it over here, I'm saying that negative 10.8 is equal to log of OH minus. What I can do from here now is say 10 to the log of the OH minus is equal 10 to the negative 10.8. And when I do the 10 to the log, I actually undo. It's like multiplying and dividing their inverse operations. So I get concentration of OH minus is equal to 10 to the negative 10.8, which is equal to 6.31 times 10 to the negative fourth. Whoops, we went to the beginning for no apparent reason. Oh, sorry, that's going to be 1.6 times 10 to the negative 11th. I was misreading my notes here. That's going to be 1.6 times 10 to the negative 11th. And actually, you may be wondering about the sig figs here. Maybe you got 1.58 times 10 to the negative 11th. Well, the rule here is that with sig figs, whoops, I will type this since writing with a stylus is a bit messy. The number of sig figs in the measurement equals the number of decimals in the log. So let me just spread that out over here. Decimals in log. There we go. So we have 2 decimal places in this log, the 2 and the 0, and that is going to be equal to the number of sig figs in the measurement. So I need to have 1.6 times 10 to the negative 11th. If I said 1.58, I would need to have a third decimal in my pH for that to be a possibility. Now, I've shown you how to go from pH down to pOH and over to OH minus concentration. You could do exactly the same. You could get the same exact answer by going to the right and then down. You always, like either way, you're going to have to do a pH or pOH to concentration conversion, which is using that 10 to the power of. It's also known as antilog. And then otherwise, you can either do your subtraction here, or you can do your division, as in this case. Either way is fine. I chose this route. You can choose your own. The important thing is to understand the process in getting from any one of these values to any other one. So I hope this video has helped. Let me know if you have any questions or comments in the comment section below. Thank you.